The chapter that was that I chose is chapter 13. So the title is Automated Enterprise Architecture, Model Maintenance via Real-Time IT Discovery. So let us try to dissect the words here because when I first read it, medyo I was not really I didn't absorb it right away. So let's first define basically the words here. So in the course of the discussions, we will be hearing of terms like enterprise architecture, enterprise architecture model maintenance, IT discovery, microservice, which earlier was also mentioned by Chris, runtime, GraphQL, and monitoring. But before that, let me just give you an idea of the different topics for today. So um, first is, of course, we'll try to define each of the keywords, and then what is enterprise architecture management, what is a microlize, what are the different architecture models, and again, as each of the chapters, the basically the editors made like an evaluation or a study for depending on the topic. So later on, I'll try to explain what was the study about and the results and the conclusion. So first, let me give you a quick diagram of an enterprise architecture of something close to me. This is actually so far the enterprise architecture of the latest database version of SAP. This is the SAP S4 HANA database enterprise architecture. So in a way, since we're discussing about enterprise architectures, let me just start this discussion with this one. So in order to understand the graph, let's go from left to right. As you can see in the left, these are the different sources of information or data. It may be your mobile, your computers, servers, and of course, people. And depending on the activity or event or transaction, may it be you're trying to procure something, you're trying to execute something, or data is passed on from the server to different computers or via Wi-Fi, or if you're trying to share like a medium, like a music or a video, each of these data are being executed in different ways. So in the middle, you can see here like concept of cloud, which in our previous course we've discussed the cloud platform, and also it could be on premise, meaning in the premises, right? And then it can also go through different um, processes or steps, or which everyone is familiar with the workflow. It goes through the different events or activities in order for it to produce something that can be used later on. Maybe it can be stored to a certain folder in a hub, or it can be organized in a certain database, shared to the World Wide Web, or you receive it as an email in your homes. So this is just a quick diagram of an enterprise architecture of, well, it not only SAP, but I guess anything that you can think of for software. So let's go back to the keywords that I mentioned earlier. So remember the title, Automated Enterprise Architecture Model Maintenance. So we're trying to automate a model of your in a way that you maintain it via real-time IT discovery. So what are these terms? Enterprise architecture is basically a way for us to be able to proactively and holistically um, respond to the different business drivers or impacts in your organization. Basically, your IT structure or your organization to basically identify how you'd be able to address this change in order for it to be aligned with your business vision or your goal. So the process of architecture is to be able to identify and analyze that for you. Um, how about the model maintenance of that enterprise architecture? These are just basically tools for us to be able to help. These are tools to help the organization in terms of analysis, support, and communication, which in a way is to help address or support the structure and dynamics of your enterprise. Now, how about ID discovery? It was mentioned in the title that it is via runtime IT discovery that be able to automate um, the maintenance of your enterprise architecture model. So, IT discovery, by its definition, is a process of mapping these different systems in a way that you'd be able to view your different infrastructures, your systems, the application itself. So that's the term for that. And then there's also a mention later on of a GraphQL. I guess everyone is familiar with SQL, which is really more of a structured query language. The difference with GraphQL, it's also a query language, but I guess it's really focused more on in this topic, which they used, the editors used this GraphQL to help assist them in terms of getting the information that they need in order for um, the study to be able to be implemented. So in definition, GraphQL is a query language and a server-side runtime for your APIs. APIs are application programming interfaces, which really gives the client what you need. So, in SQL, normally what happens there is you remember in our class before, we try to run these commands in order for us to, let's say, update, insert, delete, and create different um, data in our database. In GraphQL, it's really designed for APIs, which is really I guess it's the latest now for faster, flexible, and better for your developers. Microservice as well. It was mentioned in the earlier chapters presented today. It's an unknown architecture, um, which is really more of a collection of services that is highly testable, highly maintainable, and it can run on its own or deployed on its own. It's not dependent on other systems. It organized in around business capabilities. And runtime, I guess you guys are familiar with this. It's a time when you run your programs or execute your programs. Or by definition, it's a a program running in a computer. So that's the runtime. And lastly, monitoring. Monitoring is regular observation of the different activities and that is taking place in a certain project or a program. It's a process of gathering information in all aspects of the project. So now that we've dissected the different terminologies and words of chapter 13, I hope you guys now have like an idea of what really chapter 13 is. So we're trying to address here an automated enterprise architecture model maintenance via this real-time IT discovery. So the whole topic on chapter 13 is actually discussing this real-time IT discovery and how the study was able to prove that you will be able via the correct process get real-time or runtime information and help you with understanding your whole enterprise architecture and of course in a way be able to maintain it. So what is this chapter about? It's leveraging this service, especially using your existing IT infrastructure. So the study explains that they did not want to introduce like a new program, a new tool. Sorry, let me correct that. They want to use your existing architecture in order for you to automatically create, update, and enhance your enterprise architecture models. When we say architecture models, this is the one that I explained earlier. If you remember, so these are the analysis and tools that supports your transformation of your enterprise. Sorry, let me just go back to that slide. So why I guess the question is why are the authors trying to do this study? Um, and of course also we're trying to understand what is the reason why that we wanted to know or be able to map everything in your enterprise architecture. First is because of the rapid architectural changes. It was said that, well, I guess you guys also are aware that technology changes fast, right? So um, in an organization or in a business, it is possible that, for example, for this year, you implemented three systems. Sorry, you have three systems, and then the next year you're trying to introduce another system that would help you address a certain business driver or a business goal. And because of introducing that additional system, your whole enterprise architecture is now again different. It's entirely a new um, enterprise architecture. So because of that rapid architectural changes, the architects basically have a hard time to understand or document everything in terms of the holistic view of your enterprise architecture. Secondly, right now there are inadequate tools as well for documentation. So when I say inadequate tools, when you try to add a system into your architecture, it is possible that the existing systems documentations are already outdated. And when you're trying to introduce a new system, obviously that old system will now be a legacy system, and you're trying to introduce a new system. So in terms of mapping everything else, it is possible that what this new system is trying to offer, if you map it together, you won't have that enough data already on those legacy systems. And normally, when we try to put like a change in your enterprise architecture, the changes are really done manually. It's not automated. Then again, this is the reason again why the study was done, because they wanted to know if it's possible to automate it via runtime process. When you say runtime, again, it's the current, it's the data now. So that's the whole purpose of this study. So the whole research for chapter 13 focuses on the extraction of these components from runtime data in order to really help maintain your EA. So how? They wanted to introduce a new integration layer. Sorry, this is a new software or a new program that synchronizes the static and the runtime data. So remember, when you try to define static are those data that are not usually changed from time. Examples are, let's say, your company codes. Let's say company code 001 is, let's say, Philippines. And then company code 002 is, let's say, Malaysia or something like that. So when we're trying to, sorry, that's a country code. Let me make a different example. Let's say company code 1001 is, let's say, pertaining to your Manila site. So that's MNL or Manila. And then your 002 is, let's say, in your um, Visayas region, let's say, Iloilo site. So these data cannot be changed, or where basically they're there. It's hardly to change. Runtime data is something that is produced during that time when you run this integration layer. So via the enterprise architecture management, this is basically like the governance part. Um, it's a way for us to improve the alignment of the business and the IT. So again, remember the discussion before on the gap between the business and IT. This enterprise architecture management is the one that aligns the everything in terms of cost saving potentials, the availability, and fault tolerance. It provides you the holistic view of the entire organization, about your business, IT, and both. And of course, under EAM, there's this topic about IT landscaping modeling. It's a sub area of EAM, which is really more of the technical part to discover the documentation in your IT landscape. So, what are the challenges happening usually in EA? First is organizations usually try to shorten the release cycles. So, those who are doing software engineering, development, and project management here, it's very evident that we want things done faster. Via the, for example, the agile methodology, we release the different iterations at a very short time. And because of this, the the whole um, the whole architectural decision is basically is left to the teams, right? So the team in owning that system drives like how short should we do the release of the cycles to production? Are we going to put it at risk that of running this different tests for like 2 weeks, we're good already? So because of that, there is this notion that the architectural design of the softwares suffer, because it not basically captures the full essence, of the landscape, or that system. Second is because of the new software methodologies being introduced by like some of the microservice architecture that I mentioned earlier. It gives the team more to manage basically, and because of that, it increases the number of your models as well, or your EA models. So the more systems, the more things to manage. So this is one of the challenges there. And then lastly, most of the data that is relevant to your enterprise architecture, again, as I mentioned earlier, is done manually, um, which is really not um, reliable in terms of the first 2 points mentioned. Because the more systems you have, the faster you want to do it, and doing it manually, what will give you, right? The model that you're in your enterprise architecture model is not really that um, complete. So let's just quickly define first what's runtime. As I said earlier, it represents the true as is IT architecture of that specific point in time. Um, if you guys are familiar with APMs, the application performance monitoring tools, Dynatrace, I think this is usually more used in Java systems, App Dynamics, Instana. Just to give you an idea, these are different tools and systems that different companies can offer. Um, really a wide range of support, and help you with your different systems. Of course, if you put it in the context of enterprise architecture, these are really good tools that can help manage the architects, especially, and the business leaders to view what kind of the whole picture of their architecture. So anyway, you guys can check it out later. It's in the no, the links are there. But yeah, these are really good examples of monitoring solutions that can help address the how you'd be able to manage your enterprise architecture. So now, quickly on the concept now of the study on what they did in order to prove that you can automate um, the maintenance of your models via runtime um, discovery. They introduced this microlize. It is a new integration layer that is actually incorporated in your architecture, which really focuses more on monitoring the different informations in your system. So how do they do this? First, they of course they wanted to do a research on what are the common questions, right? First is how do you map this runtime data provided by the tools with your entities that reside in your different system sources. Later, I'll explain what are federated information sources. Second is how do you synchronize this data? The changes discovered um, via these tools. And lastly, where and how do you integrate this in your IT environment? So remember again the context, sorry, the premise of the study. They wanted to map everything and provide like a view of that you'd be able to connect everything in your architecture, right? So they created the microLICE has four components. It's the collect, hold on, collect, analyze, microLICE that store and um, expose. So by the syntax itself, it provides you the different functions of the layer or the software. First is be able to collect the runtime data. Second is to analyze it. Um, and then third is, of course, once you have the data collected and you analyze it, it stores the information into a certain database. And then lastly is you expose. Expose is it provides an interface for the architects to be able to view the architecture from end to end of the collected data for the users. So what are the different challenges introduced by or experienced by this um, microLICE tool? First is usually the techniques used in gathering the data are just sampling. Because for example, imagine you have an enterprise architecture and you're a really huge company. There will be thousands and thousands of data. So in terms of the study, what they did was just sampling. So it's not really um, because of course this is just a study for now. So they wanted just to make sure that it captures the a sample of the entirety of the architecture. Second is in the runtime data, it's just a small time frame. So maybe just a few minutes or maybe like an hour just to run and get prove that the information is gathered. And the third challenge is to be able to run the data for a specific period of time. And then usually they delete older data just to free up the storage. And lastly, when you do all the running and capturing of data, usually the data from the old um, um, the history does not contain everything that you need, and usually they just remove it, especially if it's not anymore needed for the current or the runtime execution. So how do they address it? They created an algorithm. They call it the backward discovery and the forward discovery. The backward is to reconstruct the incomplete architecture. So these are very technical already, but just imagine that via these algorithms, when the layer or the program runs, of course, they gather the data, they store it, they analyze it. If they see that there's something missing in the architecture, they analyze the historical data. Secondly, they try to fix it. Um, and then they run it with another runtime data to adapt to be able to give you the correct view or the final architecture. So other considerations I mentioned earlier about the federated data management. So these are just usually information from ongoing projects, developments, performance of your business, which usually are not available in your runtime data. So this is something that the tool considered because given it's an um, ongoing activity, um, and you're doing runtime, every time of course the data changes. So they wanted to capture that as well. And this one, the configuration file, this is actually very critical in the study because the configuration file is basically stores all the metadata that or the information that they need in order to for the microlize to run. So in this diagram, let me just sorry, this is very uh, I mean, it's too much, but basically just focus your eyes on the microlize. This is the additional layer that they introduced. The configuration file, what they just wanted to I mean, try to imagine this is like a you have like a project that you're trying to develop like a system. So you have development systems, production environment, right? So whenever you try to program or create like or let's say develop a program, every program consists of a configuration file. This configuration file basically contains all the data that you need, um, which is passed on or maintained by, of course, the developer. Once you deploy it to, let's say, production, it needs to go through first like a certain process that is aligned with the architects and the product owners. So what happens here is they use a schema or a process, the JSON schema, in order to ensure that everything that passes or every development or every system that passes through your system um, contains the necessary information. So the graph just shows that in your configuration file also, it considers your federated information system. So these are the ongoing activities, ongoing projects, etc. So basically the information that are usually not captured in a runtime. So they call it the continuous integration pipeline, which is just really ensuring that by the microlize, um, it captures all that is needed for in order for the architects to be able to view completely all these informations in your architecture. So the architecture model synchronization, it just basically identify the changes in your landscape and synchronizes them. The process results in the creation of a new entity, update it, or delete the entities. So in the synchronization, it creates three things. Now you create, you update, and you delete. So basically, these are just the result of what the microlize does. Again, earlier, remember, it tries to capture, store, analyze, and expose, right? So the end results of your tool is be able to provide like an entity in your landscape, which in a way provides the data for you to be able to have your knowledge graph. So this is where now the GraphQL enters um, um, in the picture. So the enterprise architecture knowledge graph, it's an interface where you query the data that you need. It captures all the entities in your IT landscape, and then it basically provides your stakeholders how you'd be able to traverse or to check the different um, entities in your enterprise architecture. So no, I hope by this time you understand already, guys, that via the tool and the GraphQL, it provides the architect now a whole view of the different interactions, the relationships, the data included in each of the systems, applications, whatever you have in your architecture. So that's the purpose of microlize and GraphQL. So this is just an example of a model of the enterprise graph. So remember in our class where we created the mapping, the ERD, it's somewhat like the same. It provides you the relationship between the different um, metadata in your systems. So basically, it's just a graph representation of the result of the running of the microlize. So lastly, let me just give you the result now of the evaluation done. So their users were actually they use it in a company. It's a European retailer for electronics. They have 17 experts from two companies. Um, they use the Dynatrace to do this evaluation as the APM. So the SPOC that they worked with to ensure that the documents are updated are the product owner and the team, and they found that they were able to recover via the microlize around 185 running services. So via the tool, they run it, they analyze, they found out that there were 185 running microservers in this European retailer company. 96 of the 185 Services can be assigned to their product and domain entities, though 89 of the 185, they did find that there was um, no product relationship. So there's actually a lot that they found that it has no product relationship. So and also they emphasize that 6 out of the 89 has no entity. So remember earlier via the tools be able to help you run and update it and create entities if needed. So in conclusion, after the adaptations of the models, all of the 185 now were successfully created, and it has now relationships. There were no more missing domains discovered. So the picture of the enterprise architecture is now complete. And the experts that they worked with confirmed that it's a valid approach for documenting the um, enterprise architecture of their company in an automated manner. But they just mentioned a concern that it requires actually a set of tools to become really fully operational. Remember the pipeline that I showed earlier? It has to be fully monitored, and I guess they have to assign like a certain team to do that for them. But being able to do that will really help, especially I guess the IT team who are involved in ensuring that the whole integration of their IT landscape is taken care of. So the conclusion is the research um, propose a solution that is built on the premise that they can use the existing tools, but of course, um, it would need an effort in order to execute it. And by discovering the IT landscape from runtime data and linking it to their different artifacts in their system, they're able to really capture the needed information for their enterprise architecture. Their prototype, the microlize, did not duplicate the information. It's stored in the same database. But remember, it created like a reference information, which is really needed, especially in the configuration file that I mentioned. So lastly, to enable a fully automated integration of data, they introduced validation workflows so that there is no manual work done. So there's like a steps or events that will trigger automation. So this research introduced the idea that you can query via the graph QL in order for you to be able to understand the whole picture of your enterprise architecture. So yeah, that's it. Thank you.